So you're probably saying to yourself, oh my God, there's math. No, just hold on. It's okay. Don't need to give you any bad flashbacks. The number line is the best way to describe how astronomers measure the brightness of stars. For historical reasons, the system got all complicated and messed up. I won't bore you with the historical reasons why. But astronomers use two different magnitudes, both based on the number line. The first is what's called apparent magnitude. That's how bright a star appears. Now that could be due to two factors. A star could be bright because it's close to us, or a star could look bright because it's really putting out a lot of energy. And how do we know the difference? Well, we'll talk about that when we talk about Cepheid variables. For the moment, a negative number, the leftmost on the number line, means the brighter the star appears. And the more positive the number, the more further you are on the right part of the number line, that's the dimmer the star appears. So a star that has an apparent magnitude of -1 appears brighter than a star that has an apparent magnitude of +1. The brightest appearing star in the nighttime sky is the star Sirius. Yes, as in Sirius Black in Harry Potter. The name of that character comes from the star Sirius. Sirius is the dog star. It's also where you get Sirius Radio from. That has an apparent magnitude of about -1.4. If you're in a very, very dark remote sky, you can see stars as dim as +6. With telescopes, you can see obviously much dimmer than that. The full moon, on the other hand, has an apparent magnitude of about -13, and the sun has an apparent magnitude of about -25 or 26, which gives you an idea why you should not look at the sun. Now, another thing that is a little confusing about the magnitude scale is what the difference is from one magnitude to the next. So, for example, a magnitude 1 star is brighter than a magnitude 2 star. But how much brighter? Twice as bright? 10 times as bright? 100 times as bright? Again, I won't bore you with the historical details, but each magnitude is about 2.5 times brighter than the next. Right? So a first magnitude star is 2.5 times brighter appearing than a magnitude 2 star. Now, again, this is how bright the stars appear in the sky. What about how bright they truly are, their true energy output or their luminosity? Astronomers use a similar scale, again with negative being brighter and positive being dimmer, in what we call the absolute magnitude. That's a measure of the true brightness of the star. Let's take distance out of the equation, so to speak. Imagine that I could take all the stars in the sky and put them in a police lineup. Let's say I put them all along this whiteboard ledge here. If I took distance out of the equation, if they were all the same distance away from me, then the ones that looked brighter really would be brighter. They would put out more energy. So what we do is we imagine that we could take all the stars in the sky and put them the same distance away from us, and then describe how bright they look. And that would be a measure of their true brightness, their absolute magnitude. We could have picked any distance, but to be honest, astronomers picked a number that made the math easier. Yes, astronomers like easy math too. And they picked a distance of about 33 light years. I won't go into why that makes the math easier. Okay? But if you put all the stars about 33 light years away along this chalkboard, imagine the whiteboard here was 33 light years away from me, and we look at how bright all the stars appear now that they were the same distance away, that would be our absolute magnitude. And if we compare the absolute magnitude to the apparent magnitude, in other words, how bright the star would appear if they were all the same distance away, compared to how bright the star appears at whatever distance it is, that difference gives us a measure of the distances to stars. So for any object where we know how bright it really is, what its absolute magnitude is, by comparing its absolute magnitude to its apparent magnitude, we can actually calculate its distance.